Sound the alarm, people. We've got a new technique to use here. Yes, 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 yes. So let's get into it here. We are in Unit 1, also Module 1, Topic D, and we are going to be dealing with scale drawings. We got a nice little project here for you. Ratios and proportions. So proportions is kind of the new word that's here, and we get into it right into the very first lesson that we are dealing with here. Solving a proportion. So all a proportion is, I don't want to say is, it's like using the same word. So proportions is solving, I got to question my grammar there, all right? There are two ratios that are equal to each other. So two ratios that are set equal to each other, which we would call equivalent ratios. We also use that word proportion. Proportion is going to be the main word you're going to hear moving forward. So definitely something you want to be aware of. So things are proportional if their ratios are equal. And we see this a lot there. If things kind of look awkward, as in they're not proportional, in other words, a doorway, if a doorway looks very large or too small, it's not in proportion to the things that are around it. So yeah, so we've seen these guys before, and let's kind of look at your way through it there. What we used to do is we'd be like, yay, what do you do to a 9 to get to a 27? We'd all scream times it by 3, which we do. So then we'd come down here and times it by 3, and we'd say, hey, so that means C is going to be 36 because we are timesing by 3. So that works. Over here, hey, what do you do? Well, let's multiply it by a 2. So let's do the same thing. So we'd say, yay, C equals 300. And then, yay, times 4. So times 4. So Z equals 12. Okay, so that's your equivalent ratios that we're used to. Or in other words, your proportions. What we're going to find here is we got this technique that's called cross products, because it's not always going to be crisp and clean as to what we are multiplying by. So let's see what we're talking about here. So for example, what do you multiply the 3 by to get to the 5? Yeah, a fraction, a decimal of some sort. So we have something that's referred to as cross products, and here's how this works. It's not cross division, it's cross products. The technique is similar there. We're going on that diagonal and we're going to multiply. So D times 5, well, that's 5D. Remember, when you multiply a number times a letter, just right up against each other. 20 times 3, all right, that equals 60. So now we can solve our one-step equation. Every time we use our cross products, we're going to get a one-step equation here. So we'll add both sides by 5, and we'll say, hey, D equals 12. Now, if we go into rewind that's there, you might have said, wait a second, we could have simplified 5/20ths. You're right. You can simplify the fraction that's there and still use your ratios. But again, it's not always going to work. Check out the next one. Look at that fraction of 3/4. I can't simplify it. Okay, well, what do I multiply 4 by to get to 15? Off the top of my head, it's some sort of fraction. So we don't want to deal with that. We're going to use the cross products technique. So 4 times x, 4x. 15 times 3, 45. We're going to solve our one-step equation, so we'll divide both sides by 4. Now, again, we're going to get fractions, all right? That's going to be typical. So no, don't cry about it. It's just a division problem. How many groups of 4 can you take out of 45? 11. How many pieces are left over? 1. You're trying to put them in groups of 4. Yes, fractions are our friends. There we go. 11 and 1/4. Now, if we do get to something like this where we have our decimals show up, absolutely reach for your calculator. I'm going to try to find one around here. All right. No. Okay, all right. Well, here we go. I'll type it in my phone that's there. I got a calculator here. So, yeah, let's multiply it. Go ahead, punch it in. 11 and 7/10 times 4. All right, so 11.7 times 4. We're going to get a 46.8. Now, the drawing in on the lines aren't a requirement. It's just something that I do, as in it keeps me focused. So I can see my work that I'm using here. We'll divide both sides by 5 and 2/10. All right, divide you by 5 and 2/10. Don't worry, I got it. Woo, it's a crisp clean 9. All right. So yeah, so again, cross products. All right. It's the technique we want to make use out of here. Let's do one of these guys just so we can kind of see how we can use them there. It says each elephant eats 5 pounds of food for every 100 pounds of its body weight. Okay. So 5 pounds for every 100 of its body. So 5 pounds of food. So this guy's talking about food. I don't want to say pounds and pounds. That's not going to help me clarify. And this is for its body weight. So how much does a 9,300 pound elephant eat per day? Well, that's its body weight. So here we go. I've got to keep the body weight with the body weight. So when we set things up, the labeling is nice just because it keeps things organized. Now, this is where I'd be like, hey, I'm multiplying by what, 93? Yeah. So there's no need for cross products. If I use cross products, though, I'm still going to get the same answer. So, like we say, different techniques. Cross products is what works all the time. So if you're like, well, which one's better? Well, yeah. Cross products always works, so that makes it better. Yet the equivalent ratios as which you multiply cross certainly can speed things up a little bit. So that's what we want to keep in mind. So, all right, people, that's it for today. We will see you later.